Well, good morning, good afternoon, or good evening, wherever you are today. I want to talk to you in this lesson about augmented matrices. And so the word augmented simply means to add in addition to something that's already been developed or is being developed underway. And so we're going to show you how to take a system of linear equations and how to create an augmented matrix. So let's go ahead and do that. So let's say I have 2x1 plus 3x2 equals 5. 5x1 plus 8x2 equals negative 8. Negative 3x1 minus 11x2 equals 0. Now we're not really concerned at this point whether this system has a solution or no solution, whether it's independent or dependent. We're not really concerned about that. I just want to show you how to transform this into what we're going to call an augmented matrix. And so what we do is we keep track of, using mental math, we keep track of the addition signs and the subtraction signs, and we keep track of the equations. And we notice that this right here would be a first column, and that this right here would be a second column, and that this would be a third column. So we don't even really need the variables themselves. We're just going to keep track of all the coefficients. So let's transform this now into what's called an augmented matrix. So the way that it works is we record the first column of coefficients, 2, 5, negative 3. And that first column represents the x1 column. So this represents all the coefficients times x1. Then 3, 8, negative 11. And that second column represents all the coefficients times x2. Then we have 5, negative 8, 0. And this represents all of the constants right here. So what happens is we now have an augmented matrix. In some mathematical textbooks you'll see a line here, or maybe it will be a dashed line, and they'll use that sometimes to represent that the numbers here are constants on the right hand side of the equation and they're not multiplied by any of the unknowns. We may do that, we may not. We'll kind of figure that out as we go along. But this particular matrix has 3 rows. The number of rows corresponds to the number of equations. And it also happens to have 3 columns. Now, the number of columns in this case is 1 more than the number of variables, the number of unknowns. So this is a 3 by 3 matrix. Now, if a matrix is the same number of rows and the same number of columns, we have a tendency to say that it's a square matrix. It's a square matrix, just like from geometry. And so that's an augmented matrix. So okay, let's talk about what the general solution, let's talk about what the general form of an augmented matrix would look like. And so let's write that out. General form of an augmented matrix. So let's write this mathematically. And so this right here is the general form of an augmented matrix. Remember how the subscripts work? The first number here represents the row or the equation number. And the second index here represents the column, or the, in this case, the variable that it's associated with. So this is the first row, first column. So this coefficient is times x1. Now this matrix here has n plus 1 columns, and it has m rows. And so that's the general form of an augmented matrix. Now sometimes before you can augment a system, you have to do a little bit of work. So here's 2x1 plus 11 equals negative 3x2. And here's 5x2 minus 3x1 equals 2x1 plus 8. Now, this is a system of linear equations that's not in doubt, but there's some work that has to be done here before we can augment it, because we have to have all our ducks in a row. We've got to have our variables according to subscript in some kind of increasing order. We have to have all our constants on the right-hand side of the equation. So in the first equation here, I would add 3x2 to both sides, and I would subtract 11 from both sides. So a little bit of footwork needs to be done here. So this is 2x1 plus 3x2 equals negative 11. In the second one, I would switch the negative 3x1 and the 5x2 positions. I would also subtract 2x1 to the other side, making it negative 5x1 plus 5x2 equals 8. And now, once we have all of these positions lined up the way that we want them, now we can augment this matrix. And so this becomes the matrix 2, 3, negative 5, 5, negative 11, 8. And so this thing has 2 rows, and it has 3 columns. And there's our augmented matrix. So, hopefully in this lesson, I've been able to show you a little bit about what an augmented matrix is, how to take a system of linear equations and make an augmented matrix out of it. Hopefully I've given you the idea of what the general form of an augmented matrix looks like. And I've also hopefully been able to show you, if you have a system of linear equations, sometimes there's a little bit of work to do before we can transform it into the augmented form, because things are not lined up the way they need to be. That's it for this lesson. God bless you, wherever you are today.